Hey there, I am a student from Embry-Riddle Aeronautical University, and today we are going to explore the hydrogeology of streams and the function of aquatic insects. For this specific trip, we are going to dig deep into the world of the Hemiptera order and focus on one little friend known as the Mesoveliidae for this year's macro project. The macro project joins together a diverse group of scientists, graduate students, and researchers from Mongolia, the United States, and Europe, focusing on the macrosystem ecology as it relates to river basins in major steppe regions of the world. To start off, we're going to address the watersheds and streams. I'm sure many of you are aware of how the water cycle works, but just in case, here's a recap. Precipitation is the main reason the water cycle works. After the precipitation occurs, the water is evaporated from the surface, rises into the atmosphere, then cools and condenses into rain or snow in the clouds and sits until it is ready to fall again. Now, as you can see in the picture, rivers start off as small headwater streams and continue flowing until they become rivers, then until they flow into the ocean. Water can be a very powerful and violent thing sometimes. It is amazing to see what certain insects are able to survive in. Different insects have adapted to these conditions and can withstand the violent streams, whereas others can only survive in slow or stagnant streams and pools. The shape and structure of the objects play a very big role in where they are able to survive. Take a submarine, for example. A submarine is built to withstand being completely submerged in water. But if you were to put a canoe underwater, it would not be able to serve its purpose at all. The same principle is for the insects as well. Structure plays a very big role. Have you ever noticed that streams that are narrower move faster than streams that are wider? This is because of Bernoulli's Principle, which states that at points along a horizontal streamline, higher pressure regions have lower fluid speed and lower pressure regions have higher fluid speed. If that seemed a little confusing, here's a quick experiment you can do. Grab a water hose and two nozzles with different diameters. You will notice right away that with the nozzle with the smaller diameter, the water will be moving much faster and more powerful. Now it's time to focus on our special true bug friends, the water treaders. As you can see in the picture, these cute insects have long antennae that reach out much further than their heads, long, skinny, spiny legs that have 3 segments, and big eyes. That's pretty cool. The Murray-Darling Freshwater Center has spent years conducting detailed research on the many types of freshwater invertebrates. Based on their findings, they have identified that the greenish-brown, ovoid, semi-aquatic water treaders occur in well-vegetated, stagnant water, including permanent or temporary ponds with water lilies, billabongs, and pools and riverbeds with algae growth. Some water treaders live on water-soaked moss or seeping rock faces, and there are a few records from brackish water and mangrove swamps. The water treaders are considered predators, according to William Bouchard's Guide to Aquatic Invertebrates of the Upper Midwest. Water treaders prey on invertebrates along the shore or those caught in the water surface. University of Wisconsin-Milwaukee's Bug Lady, who is a known environmental educator with years of experience, goes into further detail. She explains that water treaders feed by scavenging dead or injured insects or insects that might be stuck on the surface film. Their hunting method is to run along the surface of algae and duckweed, or sometimes even along the surface of water, until they have run down their prey. Once they have run down their prey, they inject saliva or enzymes and suck out their prey's innards. The modifications of the great water strider has encouraged researchers from Seoul National University to design a robot that acts in the same exact way. Researchers developed an ultra-lightweight robot with legs that look just like the legs of a water strider. It is coated in a water-repelling material and equipped with a torque reversal catapult to launch the robot from the surface of the water into the air. The robot is not completely finished yet, but the hardest part of getting the idea to life has already been accomplished. Overall, the water treaders are one interesting insect. I encourage you to explore more by checking out the Macro Project on Facebook and Twitter.